Good morning, ladies and gents. Welcome to the third video in the series of Btec L3 Applied Science, Unit 8, Using Statistics for Science. And this time we're going to look at the third version of fitting curves. If you remember, we looked at straight lines for fish and mass and length, and then we looked at a version of Ohm's law with current and voltage. Now we're going to look at the activity of a radioactive sample as measured once per day over a series of 10 days. So we're going to draw out the data, insert, scatter graph, just the points, and it will draw a chart that looks like that. Tidy it up as always, remove the legend, and I'll make this one a little bit bigger. Okay, so we've got something that looks kind of, well, it's not a straight line, is it? Lots going on here, but let's, as before, as always, click on the chart and we'll do layout, some titles. Horizontal title is the day, and the axis title, vertical rotated, is the activity in these units, which are BQs, which are becquerels. Okay, so there's the activity, and we're going to try and fit a line to it. So we'll start off by inserting a right click on one of the data points, add trend line, and we'll start off with our favorite, which is the linear trend line. And you see there's the linear trend line. It doesn't look at all like our data. Now what I could do is display the equation on the chart, move it up there, and we can see that even though we can generate a trend line, the R squared is only 42%, 43%, which is that line represents the data to about 40%, 42% accuracy. Now, things that follow this shape, that start particularly high, then fall very dramatically, then level off towards the end, in science that follows something called an exponential curve. Okay, so I'm going to change my trend line from linear to exponential, and instantly we see a curve that much better represents the data. And we can see here now that the R squared value of that is 0.98, which is 98% accurate. 98% fit. Okay, so we've now got a different kind of trend line. I'm going to close that away, which represents a curve this time. So unlike just in maths where we have this idea of a best fit line, in science we have this idea of a best fit curve. The same words are used to describe it in terms of this R squared value, 98% fit. This time we don't get a y equals mx plus c curve, we get a y equals some big number e to the power of something. So the equation that's generated is much more complicated to use, but it still links the day to the activity, and we've got this 98% fit. So Excel can be used to generate straight lines between data, but also it can be used to generate and fit curves between data. Thank you.